Okay, another way to attack part B is to go ahead and complete the square from the get-go in the denominator. And so as we've seen, the denominator can be rewritten as x plus 1 quantity squared plus 4. And at this point, we just make a u substitution. Let u is x be x plus 1. du and dx are the same. But now I'm going to solve for x as u minus 1. So the substitution u is x plus 1 is going to was to make the denominator u squared plus 4. The dx and du are the same, and the numerator now is 2x minus 5. That's 2u minus 1 minus 5. And so this gives us the integral 2u minus 7 over u squared plus 4 du, which I can separate as the integral of 2u over u squared plus 1 du minus the integral of 7 over u squared plus 4 du. Kind of merged together there. Now this first integral I can let, well, I can't use u again, so maybe I would use w. W is the denominator. dw is du, or 2u du. And so what I'm going to get out of this first integral is the natural log of the quantity u squared plus 4 plus a constant. And once again, I don't need the absolute values because the u squared plus 4 is always positive. From this guy, I recognize this as an arctangent form. The a squared is 4, so we pick a is 2. And so this guy is going to give us minus 7 halves arctangent u over 2 plus c. So to get our final answer, I would replace u with the x plus 1 again, and I would get the natural log of the quantity x plus 1 squared plus 4 minus 7 halves arctangent x plus 1 over 2 plus c. And if I take the time to multiply out x plus 1 quantity squared plus 4, I should get back my original denominator. To get that. This is an alternative way to do part B. It's just as fine as the first one. It's up to you how you want to proceed to do it. But this just illustrates that there are several different ways to attack an integral. Well, that'll do it for part B. Okay, part C, we have the integral 1 over the square root of 9 to the x minus 1 dx. And once again, we would first try writing this as a 9 to the x minus 1 to the negative 1/2 power, making a u substitution, and seeing if it isn't just a good old-fashioned power rule from Calc 1. Well, it turns out it isn't, because we don't have the derivative of 9 to the x lying around. So the other thing we could try is trying to match with one of these formulas, and we have a variable minus a constant, and the only time that happens is in the arcsecant formula. But it looks like we're missing all kinds of pieces. If it were to be this formula, the a squared would be 1, so a would be 1, and the u squared would be 9 to the x. And how can I write that? I could write that as something squared. Well, 9 is 3 squared, and using properties of exponents, I can interchange the x there and the 2. So I can really, if I wanted to, I could try and rewrite this as 1 over the square root of 3 to the x squared minus 1 squared. So this would let me I would want u to be 3 to the x. So the derivative du would be 3 to the x natural log 3 dx. Now the natural log of 3, although it looks a little frightening, is just a constant. We can adjust for that out front the integral, but what about this 3 to the x? If I want to get that 3 to the x in there, I'm going to have to multiply the numerator and denominator by 3 to the x, but that's actually a good thing to have that 3 to the x in the denominator, because look what I need for arcsecant. So I'm going to rewrite this as 1 over the natural log of 3 times the integral of 1 over 3 to the x times the integral 3 to the x squared minus 1, and then I've got a 3 to the x natural log of 3 dx saved off here for the du. So I'm multiplying by natural log of 3 and taking care of that by dividing by natural log of 3. I'm multiplying by 3 to the x. I'm dividing by 3 to the x. So this is meant to be the du. That's the u. And inside the radical here, I've got my u squared minus 1 squared. Alright, so now I'm all set to apply the arcsecant formula. So in the land of u, I have 1 over the natural log of 3 times the integral 1 over u square root u squared minus 1 du, which gives me, since a is 1, 1 over a is 1, absolute value u over a is absolute value u. So I just have 1 over natural log 3 arcsecant of the absolute value of u plus c. And when I take this back to x's then, it's 1 over natural log 3 arcsecant of the absolute value of 3 to the x, but that's just 3 to the x plus c. And once again, you can check your answer. Take the derivative and simplify. You should get back to the integrand. That'll do it for part C, and that'll do it for checkpoint quiz 6.